Hello everyone. I'm now going to go through part 2 of the solutions for test 1 review questions. Now we start with variance and standard deviation in this part. Now variance and standard deviation are variations of the mean, right? And variance and standard deviations are closely related, which we will see shortly. And the question is about is regarding the distance traveled by employees. So let's go through it first. It says the manager of a small dry cleaner employs 6 people. As part of their personnel file, she asked each one to record to the nearest 1/10 of a mile the distance they travel one way from home to work. The 6 distances are listed below. So this data set given here refers to miles traveled, the distance. Find the sample variance and standard deviation for the given data. Round your final answer to one more decimal place than that used for the observations. So use both the defining formula and computing formula. So there are two different formulas, but the end result should be the same. All right. And we'll first work this problem using the defining formula, and then we will go on to solving it using the computing formula. Now, let's just go over what standard deviation is about. Standard deviation refers to the average deviation of individual values from the mean. So let me write that out here. The standard deviation refers to the average deviation of individual observations from the mean, individual values or observations from the mean. That's what the standard deviation is about. Now, the defining formula is called the defining formula because it closely follows the definition of a standard deviation. And based on this definition, I can even write out the defining formula without having to memorize it. All right, so the standard deviations, the sample standard deviation is denoted by the letter S. And the formula, so I'm going to write the formula using the definition that I just wrote out here. It says the deviation of individual observations. So deviation means how much each observation deviates from the mean. How do you find that out? By finding the difference of each individual value from the mean. So it's going to be x minus x bar is what we have to first calculate. All right, we have to calculate x minus x bar, which gives us the individual deviation from the mean. But when we talk about the average involves sum of all the values divided by the number of values, correct? So we are going to apply that formula of the average to find the standard deviation. All right, so we have x minus x bar. To find the average, we have to sum up something and then divide it by n, which represents the number of values. However, when we find the sample standard deviation, it's going to be n minus 1. If we were finding the population standard deviation, the denominator would be n. But when we find the sample standard deviation, we must divide it by n minus 1 simply because it gives a closer approximation of the population to the population standard deviation. All right, now two other things we have to do to the formula is we have to square the deviations. we have to square the deviations and then sum it up, and then because we squared it, we have to take the square root eventually to undo the squaring. And there's a reason why we need to square it, which we will see when we go through this problem. All right, so to use, this is the defining formula that we are going to use. It's sigma x minus x bar, x being these individual values listed here, how much each individual value deviates from the mean, therefore x minus x bar, and then we have to square that, then sum it up, and then divide by n minus 1, and finally we have to take the square root of the whole expression. So what we did here was we first listed all the x values that were given to us, 12.7, 24.5 and all that. So all these 6 values are listed here, and then we have to, in the next column, we have to do x minus x bar, find each individual deviation from the mean. However, we need to know the sample mean. The sample mean is not given to us in the question, but you can find the sample mean by summing up all these values and dividing it by 6. So when you sum up all these values, 12.7 plus 24.5 all the way to 15.6, divided by 6, you should come up with a value of 24.42. And then you have to subtract each x value, or rather you have to subtract the mean from each individual x value. So x minus the mean, x minus x bar. So 12.7 minus 24.42 is negative 11.72. 15.6 minus 24.42 is negative 8.82. And we do the same step over and over again for each of these values. And the thing is, if we just sum it up as is, x minus x bar, if we sum up all these values, you will always end up with 0 for the sum. And that doesn't help us, right? And that is the reason why we have to square it. All right. So in the third column here, we are squaring all the values in the second column. And whenever you square, whether it's a negative value or a positive value, you always end up with a positive value. Please, all right, keep that in mind, because I do see that mistake happening on tests. So I just want to alert you to that. Whenever you square, whether it's a negative value or a positive value, you should always have a positive value for an answer. All right, so we've squared up all these values in the second column and come up with these values in the third column, and then you go ahead and sum them up, which gave us 514.906. Right, so this part 514.906 is what should go in the numerator of this expression. All right, sigma x minus x bar squared is what the numerator is, and then you just divide it by n minus 1. So n is 6, so 6 minus 1. So let's go through how it's been worked here. The question says write the defining formula. We have the defining formula written here. Then we have to find the mean of the data set. So sigma x divided by n, 146.5 divided by 6 was 24.42. So now we have to just apply the formula. So square root over 514.906, it's this value here, divided by 6 minus 1. Again, please show all your steps on the test, because every step has a point assigned to it. All right, if you miss a step, you will lose the point for that step. All right, so the final answer is 10.15. All right, so that's the standard deviation. Now the question said find the variance as well. The variance is very easy to find. Variance is whatever value you have before you find the square root. So 102.98 is the variance. Variance is the squared deviation of the mean. That means before you take the square root, whatever value is under the radical is the variance. So that's why I said variance and standard deviations are closely related to each other. All right, so that's why I have here the variance 102.98. You do not have to do a separate calculation to find the variance. You use the same process, and the variance is just one step before you take the square root. So 102.98 is the variance, and after you take the square root, it becomes the standard deviation, which is 10.15. So that was finding the variance and the standard deviation using the defining formula. Next, we will learn how to use the computing formula, and we should get the same answers for the variance and the standard deviation using the computing formula as well. We are using the same data set to find the standard deviation using the computing formula. So what we do here is, in the first column, we list those same x values that we used for using the defining formula. So these are all the x values. And then in the next column, all you do is square these individual x values. The computing formula is always faster, more efficient to use. You can find the standard deviation in fewer steps, all right, using the computing formula. That's the good thing about the computing formula. The defining formula is a little more tedious, especially if you're working with a large data set. Defining formula will take longer and it's less efficient. All right, this you can complete in fewer steps. Even if you're working through the table, you will use fewer columns when working the standard deviation. Right, so here for the computing formula, let's look at the computing formula first. This is the formula: S equals square root over sigma x squared minus sigma x whole squared divided by n. So to apply this formula, we need two quantities. One is sigma x, all right? So if you have your x values, if you sum them up, that's what your sigma x value is. So just add up all your x values, that's the data set given to you, and that will represent your sigma x. In the next column, just square up all the individual x values. So 12.7 squared is 161.29, 15.6 is 243.36, and so on. And then at the end, sum it up, and that'll be your sigma x squared. All right, sigma x squared. So that's 4091.16. And now we are ready to go ahead with the formula. We didn't have to find the mean of the data set because that's built into the formula. All right. Whereas in the defining formula, we had to find the mean. We had to take each individual x value. We had to subtract the mean and find the average, find the individual deviations first, and then we had to square in the third column. If you recall, we squared all the deviations and then we summed it up. Here, just two steps: sum up all your x values, square all your x values, then sum it up, and now we are ready to apply these values into the formula. All right, so sigma x squared is this sum total of the second column, 4091.16. That's the first term in the numerator, sigma x squared, minus then sigma x is the summed up x values, but we are going to square it based on this formula. We are going to have to square it, divided by n over n minus 1, and then we have to take the square root of the whole expression. All right, so let's plug in the value. Sigma x squared is 4091.16, and that's what we have up here. Then minus sigma x whole squared, and that's why I surrounded sigma x with brackets, because you have to square the sum of all the x values. So 146.5 squared divided by n is 6, and then this whole numerator gets divided by n minus 1, which is 6 minus 1, and you take the square root. Again, show your steps and also your calculations. It will make things easier for you. So 146.5 whole squared is 21,462 divided by 6. And then remember, division comes before addition and subtraction. So you have to complete this part, the division part in the numerator, and then subtract the result from 4091. So that's what we did here. We did the division part to get a value of 3577.041, subtracted from 4091.16, and then we end up with square root over 102.98, which is going to be the variance. And once you take the square root of that, you will get a standard deviation value of 10.15, which is exactly what we got using the defining formula. All right, so you will need to work on a problem on the test using the computing formula. I always stress on that, because the computing formula or a variation of it is used later on in statistics 2. So if any of you are going any of you will take statistics 2 in the future, then you will have to see this formula applied in several situations. All right, so that's the reason I like to introduce this and have my students learn the computing formula. All right, you don't have to memorize it. It'll be given to you on the test. If it's not on the formula sheet, it'll be given to you on the test. All right, but just know how to apply the formula and work through it. Okay. The next question is about finding the z-score given an observation, the mean, and the standard deviation. All right. So what is a z-score? Z-score tells us about the unit deviation of an observation from the mean. That means how many units a certain value is from the mean in unit standard deviation, so to speak. So to find a z-score or a standard score, z-score is also referred to as the standard score because it standardizes the deviations. All right, so it says find the z-score for a weight of 238 pounds among a population having a mean weight of 162 pounds and a standard deviation of 25.3 pounds. Round your final answer to 2 decimal places. All right, so we just have to find the z-score here. The formula, again, should be on your formula sheet. Look it up. Otherwise, but this is a simple formula. You can also, many of you may just remember it. All right, so first list all your data set. Your individual observation is 238 pounds because they want to know how much 238 pounds deviates in unit standard deviation from the mean weight of 162 pounds. So mu is 162 and the standard deviation is 25.3. So I listed out I extracted the data from the question and listed it up here up front. And then I wrote out the formula. All right, I like to have the formula before me so it's easier for me to plug in the values in the right variable where they belong. So x 238, mu mean is 162, divided by 25.3 is the standard deviation, goes in the new denominator. So 238 minus 162 is 76, divided by 25.3 is 3.0039. So this is a z-score which is 3 standard deviations away from the mean. So this, in other words, this would be considered a very high weight, very large deviation from the mean weight of 162 pounds. The next question here is says a data set has 50 observations and has mean 55 and standard deviation 10. Approximately how many observations lie between 25 and 85? Now this is a problem which also was worked out in the worksheet for this chapter or for this topic, so you may have some practice already on this. But essentially what it's asking is how many observations would lie between the values 25 and 85. And for this you have to apply your knowledge of those the empirical rule. All right, let's list that here. What did the empirical rule tell us about the percentage of observations that lie within plus minus 1 standard deviation, but plus minus 2 standard deviation, and so on. So between plus minus 1 standard deviation lie 68% of the observations. Plus minus 2 standard deviations lie 95% of the observations, and plus minus 3 standard deviations lie 99.7% of the observation. You have to memorize this. This will not be given to you on the test, or it's not on the formula sheet. You just have to know it. All right, just learn it. And then it says a data set has 50 observations. That means n is 50. Number of data is 50. Mean is 55. Sigma, the standard deviation, is 10, and the two values x individual observations, which I'm naming as x sub 1 is 25, the lower value, and the higher value x sub 2 is 85. All right, so what we have to do is we have to find the z values first, and there'll be two z values, one for x sub 1, the other one for x sub 2. So z sub 1 is 25 minus 55 divided by 10, which is negative 30, divided by 10, which is negative 3. So one of the z values is negative 3. The other one is 85. That's x sub 2 minus 55, which is the mean, divided by 10. So here we are just using the formula for z value. Let's write it up front here. It's x minus mu over sigma. Right? So we get 30 divided by 10 for z sub 2, which gives us a z sub 2 value of 3. So that means we are being asked to, the question is asking us to find out what percentage of observations would lie between minus 3. Excuse this figure though. Let me do a better job with this. So if this is our normal curve, if this is our curve, density curve, or however you may want to say it, minus 3 is going to be on the left hand side. In the center we are going to have 0, which is where the mean is located, but in terms of z values, the center point is always a 0, and then on the right hand side are the positive values, and the question is asking what percentage of values lie between negative 3 and positive 3 based on our finding of the Z1 and Z2 scores. And the rule says 99.7%, so your answer should be 99.7% observations lie between -3 and +3, but they're asking how many observations, not the percentage of observations. So what is 99.7% of what was n? 50, right? So 99.7% of 50 is 99.7% is as good as 100%, correct? So we say all 50 observations lie between 25 and 85. So that's how you're going to go about answering this problem. If it is a problem like this, you have to find the z values first to determine the unit standard deviation and then apply the empirical rule. Now, I just want to mention that there may be questions on the test which would be a little bit different, but for that, please refer to the worksheet on finding z-scores, on the topic of z-scores. All right, you may want to make sure you know how to solve those problems as well. Okay. Now, the last two questions are about the stem and leaf diagram, and also, they've given us a graphical representation of data in the form of stem and leaf diagram. And the question is on the distribution, rather the shape of the distribution. Is it a J-shaped distribution, a right-skewed distribution, a reverse J-shaped distribution, or a left-skewed? The answer is left-skewed. As we can see, if you impose a curve over the data set, you will see that the peak is, the peak is to the right, and it has somewhat long tail to the left, which makes it a left skewed distribution. All right, and then there's another one here. Here the choices are, is the distribution left skewed, right skewed, triangular, or bell-shaped? This is a bell-shaped distribution. All right, it's a bell-shaped distribution. We can just again superimpose a curve, and it is a symmetrical distribution, right? What do we have next? It says the dot plot. This is another graphic representation of data. The dot plot shows heights of wrestlers. So again, the choices are, is it left skewed, right skewed, J-shaped, or reverse J-shaped? So this one is right skewed. Again, just check it out by superimposing a curve. All right, definitely. It has a long tail. Let me do a better job here. It has a long tail to the right. Hold on one second. It has a peak to the left and a long tail to the right. Therefore, it's a right skewed distribution. All right. So in the third part of this, of the review questions, I will work on the probability questions. All right.